Okay, I'm live now. Uh, Hopefully, people can see my screen. So, can I get a response in the comment section? Can you confirm that you can see my screen? Hopefully, my screen is visible. Okay, let's see. Can you guys see my screen? Can you hear me? Can you please, if you can hear me, can you please type in the comment section or in the live chat and let me know that you can hear me and you can see my screen. Can I get confirmation? Okay, so everything seems to be okay. So let's start. So today we're covering elementary programming in Java, right? So we're covering the basics of Java. By basic, I mean like very, very basic, right? So I'm gonna split it up into like chapters, right? So in the first lecture, if you check on YouTube, there's the first lecture. The first lecture we just covered what Java is all about. It was basically the introduction into the Java space, right? So what is Java? What are objects? What is oriented programming and things like that? So now we're going to go into Java, go into Java a little bit, right? Not too much, just a little bit. So I'm going to open my text editor and then we're just going to cover a few basic things, right? So let me see. Do I have. Okay, I didn't install Throw.io, but then that's fine. So let's start with the basics. Let's start with variables, right? So anything that's related to programming, it always starts with variables. In any programming language, we're going to start with variables. So what is a variable? That's like the $1 million question. What is a variable? So if you look at the word itself, variable, right? So if you look at the term variable, you'll notice that last there's this suffix able, meaning that it's able to do something, right? So variable, so variable, so it's basically I'll say the term variable is basically a combination of vary and able, right? So in a way, that's going to give you the word variable. So what do we mean by when you say something varies, right? When you say something varies, we mean something changes. It's basically a synonym for change, something that's going to change. Or another term that they use is called mutable, right? It's mutable. It can be changed or it varies. In full, we can say it varies, it changes. So hence it's called a variable. It's able to vary or it's able to change or able to mutate, right? So it's something that varies and something that mutates. So when it comes to a variable, we understand what a variable is, like something that changes, but what is that something? So if you look at the world we live in, right, everything needs to be stored somewhere. So would be the variable because that's the container. It's a container of what? Of something. It contains something in double quotes. If you get what double quotes mean. So it's a container of something. So that something, it varies, right? It depends on what thing is being stored in there. So for example, you can pour milk into the glass. That's a different type of something or content, right? Or you can store water, or you can store juice, or you can any beverage, right? Anything that's in like liquid form, right? It wouldn't make any sense to pour what example can I make? To pour screwdrivers. You can't pour screwdrivers into a glass. There is a specific container for a specific type of data. That's what I'm trying to say. So the water or the milk, whatever the content is, would say that this is the content. Basically, the thing that's contained within the container. Another example, it could be a box, right? So you have a box full of let's say you're a parent and you have a box where you put in all the toys for your kids, right? So that box would be the container, right? Because it contains something. And then the thing within the container is content. It's that something that we're talking about, which is the toys. And a box is very good because it's big enough to contain the toys. It wouldn't make any sense for you to pour water into a box, right? Logically speaking, that wouldn't make any sense. So therefore, since we now understand that variables, they store specific type of information. So variables store specific type of information, right? Information wouldn't be the right term that I'll use there. So I would say the right type of data, right? Another term for content, we can say that's data. So variables store specific type of data, which makes sense because different containers store different things or they store different data. So since we have that understanding of variables and we can relate variables to the real world, now let's try to understand how can we achieve that in programming. So since we understand that variables have one specific type of data, how can you, okay, before we go into the type of data part or section, let's try to understand how can we name the variables, right? Remember that a box is a name, right? So box is the name of that container. And then a glass, glass, it's a container. It's a name for that specific type of container, right? So as you can see, each container has a name. So since each container has a name in the real world, remember programming is basically trying to mimic to solve real world problems computationally, right? By computationally means that in the computer. So we're trying to translate real world issues or real world problems and solve them using a computer or put them in the digital space. That's what we're trying to achieve. So hence, I'm going to reference real world examples because that's where programming evolved from. So glass, we have a box and a glass. Those are the names of those specific containers. So there's rules for naming variables or containers. There's rules for naming them in programming. So what are the rules? It's basically a simple set of rules. Each programming language has its own rules. By rules, right? I wouldn't say some rules are necessary. It's a must that you must follow them. So for example, in the real world, you can't drink and drive, right? That's a rule and you must follow that because you're going to put other people in danger. So there's some rules that whereby it's mandatory for you to follow them, and then there's some that are more of like a suggestion. So I'm gonna mix them up. So the first rule, it is actually a rule. You need to follow it. So the first rule is that a variable can contain letters, meaning letters of the alphabet, digits, and an underscore, and a dollar sign, right? Variables can contain letters, digits, an underscore, and a dollar sign. That's one of the rules. And then the second rule is that a variable, and like I said, there's rules and suggestions. This is a rule, it's a must. Hence, I'm gonna capitalize the must. A variable must start with a letter, um, must start with a letter, an underscore. Okay, let me zoom out a bit. An underscore and a dollar sign, right? But I wouldn't advise you to name variables starting with an underscore or a dollar sign. Why? Because sometimes you might make the mistake of naming a variable that's already defined in Java, and then there's going to be a conflict. So you'd rather just start with the letter. Keep it simple. Just start with the letter. And then I'm going to have this. So a variable must start with the letter, an underscore, and a dollar sign. If you didn't pick that up, remember you can also declare variables with digits in them. But a variable must not start with a digit, or it cannot start with a digit. In whatever way you want to phrase it, you can say can not start with a digit. A variable cannot start with a digit. Your program is going to fail. These are the rules that you definitely have to follow. So a variable cannot start with a digit. That's understandable. And then the other few rules. So there's rules, right? They are now the rules that I'm gonna list are more of like suggestions. After the third rule, it's more of like a suggestion. So a variable, okay, not all of them. Let me say, let me put this last one. A variable can be of any length, right? You can have, I'm gonna make examples of these variables. So these are the rows. It can be of any length. This is not really strict, as you can see, but then it's still a rule. And then what else can I include? The variable can be of any length. And then a variable, okay, now it's like suggestions, right? So let me say this is, let me just say this is more like a suggestion. So anything after this is just more like a suggestion. So a variable, so okay, I wouldn't say, let me see. Another term that we can use for variables would say an identifier, right? In your textbook, it says an identifier, which is a very good term to use because identifier, it's basically a name that is used to identify something. So it can be a variable to identify a variable, or it can be to identify a function or a class. So most of these rules apply to all of them, all of those different types of identifiers. So a variable would say that it's a type of an identifier, right? So a variable in Java can, is like I said, it can, like I said, it's not really a must. It can, well, let me just say in Java should, it's more of a suggestion, but I'm gonna use should. should be in camel case. So camel case, what it means is basically the first letter of the first letter of the first word should be a lowercase let, right? And then you capitalize the first letter of each subsequent word, right? We'll get into examples. You see, and it's called camel case the the capital letters within the variable, they sort of like represent a camel's humps, right? Hence it's called camel case. So that's one of the reason why it's called camel case. And then what else do you need to know? Yeah, and then I would say, like I said, it's more of a suggestion. A variable should have a meaningful name, right? By meaningful, it means that people should be able to sort of like get what that variable stores by just only reading its name. So we'll make examples, right? So let's make examples of variables. So for example, and we're going to apply all of these rules. So if I created a variable named $2, right, like this, that's the name of the variable. This is wrong. Why is it wrong? Incorrect because, okay, this is fine. My bad. This is fine. I wanted to make an example. Okay, it's fine. So let me do it vice versa. I wanted to make this example. So if it's $2 like that, whereby you start with a 2, this will be incorrect. And this is incorrect because variables should not start with a digit. As you can see, a variable cannot start with a digit. There's rules to these things. You need to follow them. And then, like I said, a variable can be of any length, but it's not advised to make a particular, to give a name for a variable that's way too long. So let me show you the problem with that. This is a very long variable name. This is technically correct, and your computer is gonna it's gonna be ecstatic. It's gonna be like amazing. Wow, this is an amazing variable. But in terms of user friendliness, it's not good because imagine you have a very long program and you keep using this variable. It's gonna be very long. It's gonna be hard, right? And you don't want to make the work of your co-workers or your peers very hard when they have to read your code. So you need to make sure that you don't abuse this property that a variable can be of any length. Don't abuse it, right? And then it's more, like I said, you should have a variable that's very meaningful. So it should have a meaningful name. You can't just say X. In the future, if let's say you have 15,000 lines of code, here I have 21 lines. This is very small, right? Small. It's like a few paragraphs, right? So it's very small. Let's say I have 15,000, and I reuse the same variable X, and then I have X and elsewhere. I have X elsewhere. How will I know this X means that value and this X means this value? So it becomes very cumbersome, very complicated. You do not want that. You're going to need to give your variables meaningful names. So this would be correct, right? This would be correct for small programs, right? For very small programs, like a calculator that prints, that calculates the addition of two numbers. That would be very easy, right? That's a small program, straightforward. I don't have to understand what X is. But to some extent, you have to. So it's just advisable to give meaningful names for variables. And then, since we're on the topic of meaningful names, if I declare a variable named num of studs, right, and then num studs, would you be able to understand what that actually means? You can't. You can infer that num sort of like means number, or something related to a number, but then what about studs? Do you understand what the studs mean in this case? You don't. They can mean a lot of things. So that's why this would be correct but not advised. It's not advised to do this. It's correct, but it's not advised. You should declare something more meaningful. So write it in full. So you should write it in full as number of students. And you can see I'm using the thing that I was talking about called camel case. So if you look at camel case, the first letter, which is N of the first word, remember what words are. So number is a word on its own. So number is the first word. So its first letter or character should be a lowercase letter. And then the first letter of each subsequent or each word that comes after that word, its first letter should be capitalized. So O is the first letter of, so I'm going to capitalize it. S is the first letter of students. Student is a word on its own, so I'm going to capitalize the letter S. So you see that it reads like that. And remember that variables are case sensitive, right? They're very case sensitive. What do I mean by that? So the variable x and x are not the same. The computer views them as totally different variables. So if you made a variable named x and then you call it somewhere and you say get me a capital X, you'll be like, well, there's no such thing as a capital X. So it's gonna just shout at you and throw and show you errors that something went wrong. I do not know what went wrong, but something went wrong. All I know is that X does not exist. It's gonna give you that error and say X does not exist. Then you'll be like, but how? X is there because it took into account the capitalization of your variables. It's very case sensitive. So just keep that in mind. So since we have a very deeper understanding of variables, that they're just containers of data or of information, we need to find a way to tell the computer what type of data that container stores. Remember, the type of data that container stores is very important. You need to define that. If you don't define that, as human beings, we intuitively know what type of data something should store, and we prevent ourselves from putting things that shouldn't go there. But then for a child wouldn't know. Remember, a computer is very powerful, but it's also like a child. It's like a newborn baby. You have to direct it and tell it no. So you have to be very explicit with the computer. You have to tell it no, this is the container for this specific thing. Don't try to put something other than that in that box. So you'd have to tell the computer explicitly. So what do I mean by that? So where's that? Yeah. So variables store specific type of data. We talked about that. So now we just finished talking about the variables. Now we are on this topic of type of data, right? So we are on type of data. So how does the computer know? So the computer knows by doing two things, right? By how will the computer know? You need to tell it that create a box. So how do you tell the computer to create a box? We do something called declaring or declare. To declare is just to tell the computer to make a box that stores specific things or data inside of it to be made available. So when you declare, you're just making that box or that container available for use. That's what the term declare means. So you're just basically telling the computer to make a box that stores specific things or data, right, inside of it, and you're making that box available for use, to be made available for use. That's pretty much what declaring means, right? So we're going to declare variables. So in order for us to declare variables or to make them available for use, you must tell explicitly the computer what type of content or data or things should go within the box or the container. For example, you wouldn't park a car inside the microwave, right? I mean, that's common sense. It's way too big to fit in there. And the microwave is not, that's not its job. That's not the type of content or the type of data it stores. So that's pretty much what I mean by type of data type. You want to make sure the computer doesn't make that mistake and try to put, for example, for example, for example, your kids are playing around right in the house, and then they're playing with their toys, and then they see the microwave. Let's say the microwave, it's actually on the floor. You forgot to put it back. Maybe you were shifting or doing spring cleaning, and then you forgot the microwave on the floor, and you left that the microwave door open, right? The kid is gonna go with the toy and put it inside the microwave and close, because the kid is a child. He doesn't know anything. You'd have to tell him that no, you don't put toys in there. You put them in the box. So we want to make sure the computer doesn't make that mistake like the child and try to put the toys inside the microwave. So how do we do that? We define a data type. And if you look at the word data type itself, it's a combination of data plus type, meaning that we are defining what type of data the box should only store. The keyword is only. Once you've defined that it should only store that, it only stores that. So let's talk about the different data types. So before we talk about this part of declaring the variable, we need to understand the data type. So we understand the variable, number one. We understand that it's case sensitive and things like that. It can be of any length. We understand that part. But then now we do not understand what data type is. So we need to understand data type. And then after we've done understanding data type, then we can be like, oh, okay, now we can declare a variable. So it's like, it's a bit of a process, but just bear with me. We'll declare a variable. So I'm going to change the language to Java so that it can highlight the data types as I type them. So for now, we're not going to cover a lot of data types, right? I'm not going to mainly string related data types. So I'm going to put data types that are related to like numbers and things like that. Yeah, yeah, only numbers. So let's keep it very simple. We're gonna deal with only numbers. So remember that even in math, from your math class, right, numbers can take two forms, right? They can be okay. In the most in layman's terms, right? In layman's terms, they can take two forms. Don't think about complex numbers and things like that. And sirs, don't think about that. That's beyond the scope of this tutorial. So we have integers, right? Basically numbers without a decimal point, right? And then we're going to have real numbers, which is numbers with a decimal point, right? So these are the two types of numbers that we're going to have. To keep it very basic, right? You don't have to, but to be honest, it's pretty much, this is pretty much the two numbers, excluding complex numbers. Every number is pretty much either an integer or a real number. For example, your age is an integer. Your bank balance is a real number. So you see, it's always the case, it's either integer or a real number. And you should remember integers from your math class. When you write an equation and you prove, or you make an assumption and then you say x is an element of z, z meaning integer, it's basically the same thing. So let's continue. So there's different types of integers. So there's different types of integers, right? I don't want to go into too many details explaining binary, because now I have to explain binary and then why are certain data types of a specific length. That's going to make the tutorial long, but I guess we have to cover it. So before we go into many details, right, let's try to understand. Remember, we talked about the computer. Okay, I did touch on that in the previous tutorial, lecture 0, right? Introduction to Java. So remember, a computer, it uses transistors, right? Transistors, which is basically like electrical signals or electrical switches that alternate between 1 and 0. Basically, there's either the presence of electricity or there's no presence of electricity at all. And we denote that in terms of like 1, meaning that this is on, meaning there is presence of electricity, or we can say that 0, meaning that it's off, right? And remember, we talked about the computer, its native language being ones and zeros, meaning that it can only communicate between ones and zeros. Remember, a computer is an electrical device. It gets charged up with electricity, with current, right? So obviously, it logically makes sense that that's the language that it speaks. Even though you can see everything on my screen right now, everything is beautiful, it's graphical, there's colors, beautiful colors and things like that. Under the hood is basically zeros and ones. Programmers and developers, they worked very extremely hard to make sure that a computer is user friendly. You wouldn't, it abstracts those details. It makes it's like driving a car. When you switch on the car, you don't have to understand the physics behind it, the physics behind why it's switched on, right? Before you can use the car, right? All you need to know is how to use the car. It's just like computers these days. Um, we are so abstracted from the actual technical details of the computer that we think that a computer doesn't actually speak ones and zeros. Yes, it does speak ones and zeros. Remember, when your battery is low, what do? You feed electricity into it. So it only makes sense to have on and off, one and zero, for it to be its native language. So that was a lot of explanation, but I just wanted to get that point across. So computer uses ones and zeros. You might ask yourself, if it uses ones and zeros, how can it represent numbers? That's the very important thing. Well, in order to understand how it represents numbers, we have to go back to the decimal system or the DEC system, right? The DEC system or the decimal system. DEC meaning 10. Remember, in the decimal system that we use, it's comprised of 10 numbers. Hence, it's called DEC system. Numbers starting from 0 through 9, inclusive, right? This is inclusive, 0 through 9. If it's 0 through 9, we have 10 digits. That means that we have 10 possible values that we can use to represent a number, right? So let's break that. Let's use that understanding, right? We have 10 digits to represent any number. So we understand that deck means 10, and since 10 makes sense because we have numbers 0 through 9, which is actually 10 numbers. So hence it's called the deck system. So how would we represent a number like 123? So 123 is actually a number with multiples of 10 in multiples of 10. Why is that the case? Because each digit can be represented by 10 digits. So at that position, at this position, at this position, they can all be represented by 10 digits. So let's break it down. So this will be 100 plus 20 plus 3. Simple, right? I know it sounds simple, but you'll be shocked the math behind it. I only come to find out this thing when I was reading the textbook. Actually, I'm sure we all were oblivious to this method, to how the DEC system actually works. We didn't really think put in too much of critical thinking into it. So what is 10? What is 100? 100 is 10 times 10, right? And then what is 20? So if we try to represent this summation of numbers in respect to multiples of 10 or multiplying by 10, how would we do that? That's what I'm trying to do in this next step. So 20 is basically 10 multiplied by 2. Then what would be 3? Remember your math. 3 would be 3 times 10 to the power of 0. Remember, any number to the power of 0 is equals to 1. So hence we have this. So let's now write it in terms of powers of 10, right? So this will be 10 to the power of 2, right? So this is 10 to the power of 2 because we just add the exponents 1 plus 1, basic, right? And then here I'm going to have 10 to the power of 1 because it's just 110 there. But then don't forget to multiply that whole result by 2. By 2. Multiply by 2, right? And then plus 3 times 10 to the power of 0, right? And then that's how we get 123. I know as human beings, we apply things in such an intuitive manner that we neglect the actual details details of something, right? How something actually works. Well, as you can see, every number can be represented in terms of 10. You see, there's a 10 there, 10 there, there's a 10 there. So base 10, right? So using the same methodology or approach, we can do that in any number system or any base system. So this is DEC or base 10 system. Another term for this is base 10, right? This will be called the base, I think it's called base 10, right? Base 10 meaning DEC, it's a DEC system. There's 10 values or 10 digits to represent any number. So this will be it. So remember, if you start counting from the right from the most far right, from the most right side, which is 3, right? From this side going that way. As you can see, if you look at the exponents, they increase by 1. Remember, this is the ones place, right? Hence, this will be 10 to the power of 0. So 0, you see that it was 0, and then it increased to 1, increased to 2, and then it increased to 3, 4, to the power of 4, to the power of 5, to the power of 6, and so forth. So that same approach to represent any number is the same approach that we're going to use in the binary number system. So binary number system, we have two values, 0, 0 or 1. Okay, let me say 0 and 1 to represent any number, right? So since we have that those 1 and 0s represent any number, how can we represent any number? So basically, what would be this base? This will be base 2 because we have two values or two numbers. Hence, it's called binary. Bi meaning 2, 0 and 1. So hence, it's called binary number system. So if I wanted to represent a number, you can put it in terms of base 2, right? So let's say you wanted to represent this number, right? This will be basically, remember, starting from the far right, it's the ones place, and then we increment going to the left hand side. So it's like it starts at 0, and then you go to the left hand side. It increases the more you go. It increases by 1, meaning the exponents. So this number, when you actually translate it to a decimal, to an actual number, like in the DEC system, this will just be 1 times base 2. Remember, we use base 10 here because there were 10 possible values. Here we're using base 2 because there's 2 possible values. 2 to the power of 1 plus 0 times 2 to the power of 0. As you can see, it's very identical. It's basically the same thing. The only difference is the number of digits being used in that number system. So in the binary system or the binary number system, we only have two values. So this is how it will be represented. So this basically translates to 2 plus 0, which actually equals to the decimal number 2. So 10 in binary, it actually means 2 in decimal number system. So now I can make this joke. There are types of people. One, the ones who understand binary and the ones who don't. If you get it, you get it. There are 10 types. If you don't understand, you're going to read it as there are 10 types. But remember, 10, this is just 2. So this just means there are 2 types of people: those who understand binary and those who don't. So that's the joke of the day. So we pretty much have a deeper understanding now, right? Of how numbers are represented in the binary number system. I want you to have that mental image so that when you create the variables and we use all these data types, you understand, oh, so this would mean this and that, okay? That's very important to have that mental image. So let's see how we can declare variables. How to declare variables. Right, so how do you declare variable? Remember what we talked about. What does the term declare mean? To declare, it means to tell the computer to make a box that stores specific things or data inside of it to be made available for use. That's basically what we're doing. So we are telling the computer, basically now we're instructing the computer to create that box. Remember programming, don't forget programming, basically with programming, it's like you're a parent. That's the most basic way to put it. You're like a parent and the computer is a child. So if you fail to groom the child and and instruct the child to do specific things, then the blame is on you because the computer is very explicit. It's like a child. If for example, if you tell your child to go put eggs in the bowl, does your first of all does the child know what the command put actually means? And second, does the child actually knows what you mean by put? Besides understanding what put means, but what do you actually mean? Do you mean I should crack them open or what? The child will literally put the eggs in the flour as they are with the shell, with the shell and everything. So that's the computer. It's like a child. You are the parent. You have to instruct it to do specific things. If your instructions are very vague, then you're gonna have issues. It's gonna do things that you didn't expect it to do because your instructions were not clear enough. So let's see how to do that. To declare, you type in the data type first, and then you put in a space. You see this space. If you forget this space, you're gonna have issues again. This space is very important. You need that one space. It doesn't matter how many spaces you need, but at least a space, at least one space. Space. You type. You put in the data type followed by a space, and then followed by the name of variable. Right, so the name of the variable, and then that's pretty much how you do it. So we are talking about how to declare, but we didn't talk about the list of the data types. So let's talk about the data types. So we have different types of integers. So why different type of integers? We have different types of integers because each integer stores a limited range of integers. So it's based on a range, right? It's like if you remember on the number plane and things like that, the range inside your math class, you know what a range and a domain is, all those things. But you need to remember that now. So it's stored in a specific range. By range, I mean it's like from 1 to. That's what I mean by range. So remember, computer memory is limited. Remember, in the real world, things are infinite, right? There's an infinite number of integers and an infinite number of real numbers and infinite numbers of numbers between two numbers again. So we live in an infinite world, right? There's an infinite number of possibilities. So with the computer, there's this thing called memory. We talked about it in the previous lecture. Memory is limited. You can't have a computer that doesn't run out of memory. There's no such a thing. Maybe in the future they're going to create it, but for now we don't have that. Memory is limited. You do run out of memory at some point. By memory, it's like, let me make an analogy based on your phone. For example, when you try to download something or install an app and it says, especially for Android users, and it says you need to delete an app. You see, that point in time, you do not have enough memory. So you ran out of memory. So that's very important. You need to understand that. So hence, since we are limited with memory, there's also a limited amount of values we can represent. So since there's limited amount of values we can represent, there's also different ranges of integers and different ranges of real numbers. So let's start with integers. So we start with the byte data type. So as you can see, it's highlighted, right? You need to find the right text editor or integrated development environment to use so that it can highlight it so that you know which of the things are part of Java, right? So byte, as you can see, it's part of it's highlighted to show that it's part of Java. So a byte, right, is basically 8 bits. We talked about bits being binary digits, right? Binary digits meaning 0 and 1. That's basically it. So basically, when you have byte, you have 8 of them. You have eight zeros and ones. So that's basically what it means. And then to represent the range, right, you'd have to start from to represent a range to find the range of a data type, right? You'd say it starts from -2. Remember, we're using base 2 because there's two possible numbers, which is the 0 and the 1. So -2 to the power of the number of bits -1 up to +2 to the power of bits -1, and then that result that you get, right, after doing all of this thing, right, after saying 2 to the power of, you subtract 1 from it. You subtract, if when I read the textbook, they said you subtract 1 because the 0 is part of the range, if I'm not something like that, right? Something like that. But yeah, don't forget to subtract the -1 at the top there. So by B, I mean the number of bits that are there. By number of bits, I mean binary digits. So since byte can use a max of 8, that means I need to replace B with 8. So this will be 8 minus 1, which is just 7. So this will be 2 to the power of 7. And then this is also 7. So 2 to the power of 7. So the range is -2 to the power of 7 up until +2 to the power of 7 minus 1. In actual integers, right, so that it's clear to understand, it's from -128 to the positive number 127. So basically, if you have an integer that's within this range, you should use the byte data type. Remember what I said, memory is limited. Make sure you preserve the memory. So for example, you can technically use a byte to store the age of a person in a computer, because you wouldn't expect anyone to go up until 127 years, right? You wouldn't expect that, right? That's not the normal life expectancy. There is people who've lived beyond that, but nowadays, generally speaking, you can use a byte, so you don't expect anyone to go beyond 127 years, right? And then after a byte, we have the short data type. And keep in mind that with data types, right? Each new data type that follows or that comes underneath, I'm listing them in terms of from in ascending order. So since it's an ascending order, just expect the number of bits to keep on increasing. So how does it increase? You always multiply the previous data type's number of bits, you multiply them by 2. So the previous one is 8 bits, so that means the next one will be 16 bits. And then you apply that formula from -2 to the power of 15 to +2 to the power of 15 and things like that. You now know the formula, that this is the formula. It's for range of data type, you can find it this way: from -2 to the power of b minus 1 up until +2 to the power of b minus 1, and then the result you subtract 1 to it. Where, remember in math, you have to specify what that variable means in that equation, or in that, yeah, in that equation. So b in this case represents bits, where b is an element of number of bits. I'm trying to act cool, so I'm gonna say where b is an element of, yeah. So basically b represents the number of bits. Don't worry about these nodes. They'll be there on the under the description of the video. There should be a link where you can download this text file. So we have short, and then after short we have int, which is 32 bits. So as you can see, it doubles every time. And then we have long, which is 64 bits. And then in the future, when you deal with things like data structures or very, very big applications, right? Like very big, you're gonna have something called the big integer, right? This is not really a type. It's more of it's an object, right? It's a class. So I'm not gonna include it in this scenario because we are talking about the. I forgot to use that term. It's called primitive. These are called primitive types. Primitive or fundamental, right? Or fundamental. Fundamental just means like the basic types. So with these types, you can use these types to form other types, like things like that. That's basically fundamental. They're just fundamental. They're just the most primitive, the most fundamental types that Java has. And then we have the last two, which is for real numbers, right? We have two. We have float, which is 32 bits, IEEE 754 if I'm not mistaken, and then double 64 bits, IEEE 754. You might ask about what is the IEEE? IEEE is it's a standardization of how real numbers should be represented in computers. It's based on that standard. That's what it means. So it's 32 bits based on this standard. They might ask you for those. You might ask in the test. So I suggest you know it. So IEEE stands for. I hope I can remember it. It's Institute of It's Institute of Electrical and Electronics Engineers. Engineers, right? So it's the Institute of Electrical and Electronics Engineers. So you can go on Google and find out more about how floating points, how real numbers are represented in a computer. So real numbers, you might ask yourself, why am I saying floating point, floating point? What does that mean? So real numbers in computers are stored, right? So let me make some notes here. They are stored using a method called floating point, right? They're stored using a method called floating point. Hence, we have this data type called float. Because if you look at floating, it has the keyword float. So with float, since it's using a method called floating point, so this will be called a single precision, right? And then this will be double precision. By double precision meaning that basically accuracy in terms of like the number of decimal places it can represent. So this uses single floating point precision. This uses double precision, right? Double meaning it's twice, which makes sense because you can also look at the number of bits that are being used. It uses 32, this one, 64, which is this double uses 64, which is double the floating point. So with if I'm not mistaken, with floating point, it's 6 to 7 um, digits, right? After the decimal point, you can you can represent up to 6 or 7 decimal places basically. And then this one is from 14 to 16 decimal places, around that area, right? It depends on your computer too and things like that. So this might not necessarily be accurate, but we'll see when we run our a basic program, right? So we have these data types. Yeah, I know it's quite a lot of information to take in, but yeah, it's programming is just like that. You have to there's quite a lot to learn if you really want to master it. So we have the data type and then name of variable. So we're here. We now know the different data types. We now know how to name or to give the variable a name the proper way. So let's make examples, right? So let's say you want to declare an integer, right, to represent someone's age. Like I said, you can use byte, but for the purpose of this tutorial, I'm just going to use int. I'm going to use an integer. So int age, then semicolon. Do not forget the semicolon because the semicolon, it basically means, has the same meaning as a period in a sentence, right? Remember what a period is, or a dot. It means that that's the end of the sentence, right? So the same applies in programming. You have to tell it, oh, this is the end of my declaration. This is where the declaring part ends. I'm ending it there. Failure to do so, your code is going to crash. You're going to have errors. So as you can see, this is a simple variable int age, and then you can also declare a float, and then float, let's say marks, right? So these are your marks. So this is different ways of declaring variables. So now let's learn about how to give the variables values, right? So basically how to put data into the boxes. Remember this, when I say int age, I'm basically telling the computer to create a box with the label age, and that box can only store integers. And what integers is basically integers of this specific range. So if it's out of range, it's going to throw an error. So that's another thing you should be very careful of. That's why we just use an int to just be safe, because with an integer you can represent up to 2 billion, a number that reaches up to 2 billion, of which the programs or the apps that you guys will be making, they'll probably not reach that. Yeah, they won't. Yeah, they're probably not gonna reach that. And then floating point, and then yeah. So let's see how to initialize the values, right? The variables, right? So you basically have the name of the variable here. Name of variable is equals to some value, and then do not forget the semicolon. Semicolon is very important. It means to terminate, to say that's where that statement. In coding, we don't call them sentences, we call them statements. So this is where the statement ends. So that semicolon is very important. So let's say I wanted to initialize the age. Let's say the person is like 21 years old, right? So I would initialize that box like this. These spaces in between here, they are not necessary, but they make it easy to read. Um, they make it look very demure, right? Very pretty. So that's as I advise you do that. You can also leave it like this, which is still fine, but then you see how it looks. It doesn't look proper, so that's why we tend to put spaces like this. So unlike in math, right? Remember in math, the equal sign is more like the left hand side is equal to the right hand side. That's more what it represents. In coding, this equal sign is actually an assignment operator. This is called an how am I okay. So this will be an assignment operator, right? So this means you are assigning a value to that box, or you are sort of like you're putting something into that box, but they call it assignment. We are assigning it a value, right? But it basically means the same thing. You're putting something into the box. That's what it means. So that would be an assignment operator. So since we're on this notion of operators, right? Let's talk about the different operators that are possible in Java. So we have the addition, which is the plus that you know very well. We have the minus to subtract, which you guys know very well. And then we have the division. So if you remember division, sort of it has circles, whatever. In this case, if you remember division, right, the division symbol looks like this, right? You have sort of like a circle on the top, and then you have a circle on the bottom like this, sort of like that. In programming, you see how complicated it would be to represent that. So we just use a forward slash to represent division. So this will be addition, and then this will be subtraction, to subtract one value from another, and then this will be division. But then be very careful about this division. This is what we call integer division, meaning that you get back the quotient, right? You get the quotient. So it's an integer division. You get back and basically get back another integer. Just just always remember that. And then we have the modulus, or mod, or remainder, right? Which basically gets the remainder. If this one gets the quotient, which is the division, this one gets the remainder. I mean, personally speaking, this would have been fine to say this just divides and then you get back a floating point. But yeah, that's how they did it. This is how the Java works. You'd have to understand these rules. If you're coming from another programming language, I'm sure by now you'd be bored. You'd be like, well, I already know this. Yeah, it's pretty. If you realize when you know one language, it's easy to go to another language. Most of the things are the same. It's just some languages tend to have their own unique things, but then at the end of the day, it's basically the same thing. So how can we use these operators, right? The way we can use these operators is, remember what I said. We have to work with an assignment operator. So remember, an assignment operator, the way it works is that on the right hand side you have an expression, right? So this value is actually what we call an expression, and the expression can come in two forms, whereby you have an expression with these operators, or something called a literal expression. So by literal, it's in the word itself. Literal. It's literally that thing. So for example, if when it comes here, age is equals to 21. So we would say 21 is a literal expression. By that I mean 21 is literally an integer. That's what it means. So 21 is literally an integer, a literal expression. So that's what it would mean. And then this would be and then the other expression would involve these operators. So let's see other operators, right? How can we use them? So remember, you need to assign something. You put the name of the variable on the left hand side, followed by space, followed by an equal sign, followed by space, and then followed by the expression here, and then followed by a semicolon. So what would be the expression? In this case, let's make it something simple, right? So let's say we are summing up the marks that you got. Let's say you got 10 on the quiz. For your quiz, you got 10%, or it was out of 10% and you got all of it. And then there was a semester test that was out of 80%, and you happen to get 65, but it's out of 80. And then there was another project that you were supposed to do, which was 10%, and you managed to get 8%. So this would be the expression, right? As you can see, this is the expression. But in this expression, it includes literal expressions. By literal expression, it means that it includes literal values or literal integers. So I have an integer and an integer and an integer. So I have literal values or literal expressions. You can also mix it and put in other variables, right? It's possible to mix variables and other values. There's multiple ways to do this thing. So you can have, for example, int. So I need to declare it first. Remember, remember, you cannot, another important rule is that you cannot use a variable. So let me do this. So let me cut this and put it down there so that you see that I declared the variables before I used them. You cannot just say marks. It's going to ask you where's marks coming from. You need to declare it first, make it available for use. So hence I'm going to declare here and say this is your class test, and then you got 10% for that. And then here I'm just going to replace that 10 with the class test. Unlike in math, like I said, this is not this is not an equation. This doesn't mean that marks is equals to that. No, it means that solve what's on the right hand side and then assign it or store it inside marks, inside the box with the label marks. That's what it means. So when you use a variable like this, what does the computer do? The computer, what it does, especially if it's on the right hand side, that I'm explaining when the variable is on the right hand side. What it does is that it goes and looks for that variable where it was declared and its value. Okay, I'm skipping a lot of things here. I'm sure you've noticed you can actually do two things. You can declare and assign. You see, I've combined the two steps. Here I declared only, and then here I'm assigning in another step. Here I've combined them, right? You can do it in two ways. This, when it's declared like this is what it means in other words. It means that I've declared it like this, and then I did this. But then you see that it's two unnecessary lines that I can just combine into one. So I'm going to delete that and just combine the declaration and the assignment into a one statement. So what happens is I was explaining, when it sees class test on the right hand side or a variable on the right hand side, it goes into your computer, into the memory, onto the RAM, right? And it looks for a variable with that name, right? Or a box with that label. And then sees, oh, there it is. And then, oh, the value is 10. And then it comes here, it extracts that value and then it puts it there. That's the magic that's be happening behind the scenes. So just keep that in mind, that this actually makes sense. Don't be confused. So we have class test plus that integer, and then whatever this result is, store it into marks. So that's pretty much what's happening there. So we have an understanding of operators, and the same applies to division, multiplication. You can also put division here. You can do the modulus operator or the division operator, or I forgot something, the multiplication. So you use the asterisk for multiplication. I felt like I knew something was missing, but yeah, multiplication to multiply values, right? So you can use that. So you can come here and just say class test times class test, which should give you 100, right? Because 10 times 10 is 100. So yeah, that's pretty much how you use operators. Just make sure on the left hand side you have another expression, whether it's a literal expression or another expression including other operators, which is going to result in some value. And then the same applies to the right hand side. And you might ask yourself, what would happen in the case that I have class test times class test plus 10, for example, or plus 50, let's say plus 50. What would happen? Well, you have to go back to remember what you were taught by your math teacher, that there's this thing called BODMAS, right? Some call it, they have different acronyms for it, but you start with what's in the brackets, right? And then you do division. So division comes before multiplication, and then after multiplication comes addition, and then finally subtraction. So there's an order of operation, right? So since multiplication comes before addition, would say that it has a higher precedence, right? So that means multiplication will be executed first before we do addition. So that means the answer here will be 100 times 10 times 10, which is 100, plus 50, which is going to be 110, 50. So that's something you should keep in mind. So we have this, and we have something called it's called augmented operators, right? So augmented in a way just means like combined, right? You can combine two operators, right? So this is applicable when you are reusing that same variable and reassigning it and reassigning a new value into the same variable. So what do I mean? So for example, you have marks and you wanna take the current marks, right? Let's say maybe the student there's bonus marks, right? So the student you look at the current marks and then you give them a 25% bonus marks, right? So as you can see, I have the same variable on both sides. Remember, when the assignment operator, it executes what's on the right hand side first before it goes to the um, to the left hand side. So that process of executing the right hand side first, we say that it's right associative, right? Meaning that it starts on the right hand side and then it goes to the left. And then if it's vice versa, we'll say that it's left associative, right? Meaning that it starts from the left and goes to the right. So that's something those are the terms that you should know. So it's the assignment operator, it's right associative, meaning that it starts with what's on the right. Remember, an assignment is still another operator. So I have this on the left and then I have all of this on the right. So since it's right associative, it's going to start with what's on the right hand side. So it's going to go into marks. What is currently inside marks? It's 150. And then that 150, it's going to add 25%. And then that would be 175, right? And then you don't have to worry about that it exceeds 100%. That's not the main point. I'm just showing you examples. So with this, you see that it's a bit unnecessary for me to rewrite the same variable. Programmers in Java came up with a shorthand for it. So a shorthand for this, or a shortcut. So you say marks plus equals. So that's what we mean by augmented operators. So plus equals 25. So you can imagine this is what happens. You remove that, right? And then you do this, but then that actually means the same thing. So this means the same thing as this, right? It's exactly the same thing. And the same applies with other operators. Division equals, module equals, times equals. You can do the same thing with all the other operators. Or the same still applies. Minus equals, you can do the same thing. This applies to all the operators, right? So this will be the shorthand. So these are called augmented operators. And then I think the last thing that we should cover is the increment and decrement operators, and then we should be basically done. Then I'm going to make a simple program with not necessarily done. I still haven't talked about output and input. So we're left with two things to discuss: the increment and decrement operators. Then we're going to discuss system output and system input. So increment and decrement operators, right? So increment and decrement operators. So what's the whole point of increment and decrement? So increment and decrement, right? Increment just means to add one or to increase by one, and then this one means decrement means subtract by one, so reduce by one. So we can use this shorthand approach. So basically, the shorthand approach, right? This only applies if you're adding one, only the integer one. That's the only time that applies. So if you have marks plus equals 1 semicolon like this can be abbreviated to marks plus plus, right? So this plus plus is called a post increment, right? It's an increment operator, but then it's post. You should pay attention to this thing. It's very important to understand. It's called post because it's after the variable, right? As you can see, it's after the variable, and then pre. If it's before the variable, we call that pre increment. So since it's after, I'm gonna call it post increment. I'm gonna explain the difference, like the order. So this would be post pre increment, and then same applies with decrement. Remember, I said only when you're subtracting or adding by one. So with decrement, it has to be something like max minus equal 1, like this, meaning that I'm subtracting 1. I can abbreviate this to just max minus minus. Don't forget the semicolons to terminate. Or I can say minus minus max, like this. So this would be post decrement. And then this will be pre decrement. So what is the difference between pre and post? So pre, when remember, decrement or increment, it doesn't matter. That's not the point. The main point you need to understand, or the keywords you need to understand, is pre and post. So when you say pre, right, anything that is pre increment, pre decrement, as long as it has a pre, right, it means that before retrieving or getting the value or retrieving the value, update it, right? That's what it means. And then post, it's vice versa. After you've retrieved, so after retrieving the value, then update it. That's pretty much what pre and post increment and decrement mean. So pre, it means before retrieving it, update it. So you get the new value, you don't get the old value. With post, what happens is that you get the old value first and then it updates it after. So that means you're gonna always get the old value with post. So that's very important to understand. So let's say, let me explain this let me make an example to make it a bit simpler. So let's say I had a 1 here, right? Let's say I previously initialized marks to 1. Remember, when it's like this, it's an initialization statement. I'm giving it an initial value. So whatever was there is going to be deleted. So whatever marks had inside is going to be erased or deleted, right? So when you have, so let's skip this. So when you have post increment, right, what happens is that I'm gonna get the value 1 first, and then it's gonna update it, then update it to 2. So I get the value first, and it's called post increment. So that means after you've gotten the value, then you can update marks. So it's gonna get 1 and then update it after you've extracted the value. But then you can only get the value if you've stored this in a variable, right? If you just leave it like that, the pre and post increment basically have the same effect. If you just leave it like that, I'm going to demonstrate in code when we write code now. But yeah, it pretty much has the same effect if you don't store the answer in a variable. So keep that in mind. If you just leave it like that, they basically have the same effect. So pre is before retrieving the value updated. So that means you get the new value. And then post is after retrieving the value, then update it. That means you get the old value. So here you get old value, and then here you get new value. So that's the difference between pre and post. And then now we're going to discuss system input and output. So that's the last thing we want to discuss, and then I'm just going to show you a basic example, and then that'll be the end of this stream. So let's discuss system input and output. So in remember, a computer or something or a program, in order for it to be effective, we need to get information, right? We need to get input, right? So let's make a simple example, right? So let me save this. Let me create a Java program, right? So remember, I'm gonna need to say public. So Java. So I'm gonna need to say public class, right? And then I'm gonna give it a name, and then I need to put curly braces like this. You need to make sure you put the curly braces. That's a mandatory thing. You need to do exactly that. And then I need to declare the function. So public static void main, which takes in a string, an array of strings. You don't have to know about that yet. You just need to understand this structure. And remember, when you create a Java application, right, or a Java file, the name of this class needs to match with the name of your Java file. They need to match exactly, even the capitalization and everything. So I'm gonna save this file. So let me save it on downloads, and then I'm gonna I copied that class name, right? So I'm gonna press Control V to paste the class name. So as you can see, the names match. Class is main, and here it's called main.java. That .java extension is very important so that when you try to translate this program into the machine's native language, it will know that this is a Java file. This contains Java code. So I'm gonna save, and then there we go. And then let's create a simple program, right? A program that calculates the area of a circle, right? So area of a circle. So it calculates the area of a circle. So I'm gonna use doubles, right? You can use whatever you wanna use, but I'm gonna use doubles. So I'm gonna have a radius, right? So let's say the radius is 10, right? So in order for you to, okay, let me say radius and then pi, and then I'm gonna calculate, I'm gonna have the area. Okay, I could just do this. You don't have to do it the way I'm doing it, but I could just do this. So area of the circle, right? So this is what we call comments, right? Comments basically like a note, right? A note for you to remember when you look at your code in the future to be like, oh, this was calculating the area of a circle. Okay, I understand what the program does, because you might not actually remember what you wrote if you don't explain it. In my case, I use meaningful names. Comments are useful, for example, if you just say this is R and this is A. How will anyone know what this program does if it does? Number one, it is no comment. Number two, the variable names are not meaningful. So that's why comments are very useful. It's just something to, like a note for your future self, and for other developers to understand what your application does, or the code what it actually does. So you just put in two forward slashes and then a space, and then you start typing the text or explain what your code does. So two forward slashes, and then here I'm going to say declare my variables, right? And then here I'm going to say initialize my variables. So I'm going to initialize my variables. So I'm going to give them an initial value. So let's say the radius is, let's make it 25. So when you're initializing things like doubles and floats, right, real numbers, especially real numbers, right, you need to append a character, a letter at the end. And you need to make sure you write it in a real, you can leave it as an integer, like an integer literal, that's fine. But I like to make it a double like this. So when you say 25.0, right, or dot zero, the compiler or the Java, right, Java basically it assumes by default that this is a double, right? So it assumes by default that it's a double, which is fine in this case. I don't have to worry about that. But if I had floats, then it's going to be an issue, because I'm trying to put into a box that's only stores floats, and I'm trying to put it double. That's when we end up having issues. So in this case, I'm not going to have any issues, because this by default is interpreted as a double, and I have a double this side, so that's fine. Then my area um, is going to be equal to radius. Remember, it's pi r squared, right? So radius times pi. But what is pi? So I need to put in the actual value of pi. So 3.14159, right? So this would be pi, right? I don't have to put in all the digits, just only put in a couple of the digits, that's fine. And then this will be the area, right? I've calculated my area. So this will be the program. So if you run this program, right, nothing happens. Why does nothing happen? Because we can't see what has happened. Hence, this thing called system input and system output. So we need to be able to interact. The app needs to interact with the user so that the user gets a response. They know, oh, so it calculated well or everything went well. So we need to get a response. So in order to get a response, right, we need to use functions or classes or tools inside Java that helps us to output and get input from the user. So by default, um, what is the system output? By default, it is linked to your monitor, right, to your screen. That's the not system output, the output drives, right? Yeah, I'll say the output drives by default it's linked to your monitor, right? As you can see, I'm typing something and you can see it through your monitor and through my own monitor, right? So that'll be the standard output drive, right? It's linked to your monitor. But in terms of programming, it's technically linked to the monitor, but it's linked to the monitor via the terminal, something that we call the terminal. In my case, I do not have the command prompt, right? That I removed it. I use PowerShell. So this is what we call the terminal, right? This is the terminal, right? This is what we call the terminal or the console. So this is the console. So I'm gonna leave it open because I'm gonna run some commands there to so that our program gives us a response. It's linked to your monitor by default in Java. It is linked to your terminal. Terminal. So it's linked to your terminal, right? So when you send output, it's going to be shown in the terminal. So you need to have a terminal open in order for you to see the output. And then in order for us to get input, the computer uses input drives, right? And your input drives by default they're linked. The input drives it can be anything. You can change it to be to be the console, like the console, the gaming console for those gamers out there. You can use that gaming console to actually use that to get input, right? You can do that. But then by default it is linked to your keyboard. Because as you can see, the first time you get your computer and you start typing, the input when you type, do you have to get an external keyboard or something, or you just use the keyboard that came with the computer, and then you start seeing what you're typing on the screen? So as you can see, it is indeed linked to your keyboard, the input drive. So that's how. So when I'm typing right now, it's going to serve as input to Notepad++. Notepad++ is getting this input from me through what the keyboard. I'm typing on the keyboard. So that's how we're going to get input from the user. So we're going to discuss ways on how to get input and output. So how to get input, right? Okay, let's start with output. How to output. So how to output, you have to use go to the system class, right? And then you access the out object. So use system.out, right? I guess I should have said system.out is linked to your monitor. Okay, it's fine. It's fine. Let me phrase it this way. Let me phrase it this way. I'm gonna say here this is linked. System.out is linked to your terminal. You're gonna see the output on the terminal. Basically, that's what it means. You're gonna see the output on the terminal, and to output to the terminal or to send output to the terminal, you have to make use of this object, right? The out object. So you can imagine behind the scenes, this is how it looks. Out is actually it's a type of output stream object. So it's out like this. So this is declared. This out object is declared as output stream. This is a type, right? It's called output stream. It exists inside Java. Output stream, and then we have input stream declared as in, which can be accessed via system.in, which is linked to your keyboard, right? It is linked to your keyboard. So this is pretty much how we're going to make use of standard of input and output and things like that. For output, right, just mainly for output, to output you must call the print or the print line function, right? So there's there's three. There's printf for formatted, then there's print normal print, then there's print l, which stands for print line. Basically it prints okay, let me connect my charger. It prints print ln, it prints that specific text, right, that you want to print, or a value to the terminal or to the monitor, right, to do that in this scenario in the terminal, to the terminal, and it moves the cursor to the next line. So the cursor is this thing that's blinking here. You see this thing, this line that's blinking, we call that the cursor. So when you use print line, so it's going to print whatever text that is, it keeps on printing until it reaches the end, and then it moves on to the next line like that. So that means the next text that will be displayed on the next line. Hence, this is called print line function. So how many functions can you call inside to print? You say system.out.println. That's the first function. And then the second function is just print, and then the third is just print f for formatted output. So these are the three types of functions to use that to print to the standard output. And then to get input from the user, you can use many things. You can use a buffered read and things like that, but in this case we're just going to keep it simple. We're going to use a scanner class to read input, right? So how we're going to do that, we need to create the scanner. So I'm going to say scanner, and then I'm going to give it a name and call it scanner. Its type is scanner, and then its name I'm going to call it scan or scan. You can call it scan or scan. Let me just say scan. And then you need to initialize it, right? You could just leave it like this and then initialize in the next line. That's fine. But remember, I like to combine the steps, declaring and initializing. I like to combine them to make my work simpler. And then you're going to say new scanner. So by new scanner, it means that give me a new object of that thing, right? That scanner. A scanner can view it in terms of like when you're at a shopping center and they say, when the cashier scans your product, right? They scan your product. So in this case, we are scanning the input. Remember when they scan the barcode, right? Or the QR code, whatever that code is, they scan it so that they can flag, so that it doesn't, so that the alarm doesn't go off when you leave the store, to denote that you've actually purchased the product. They scan it, right? So it's the same concept or the same terminology here. We are scanning what are we supposed to scan? We need to tell it what we want it to scan. We need to pass it inside the round brackets. This new just says give me a new scanner. For example, I bought a new car, a new scanner, things like that. So you create a new scanner. And then within the round brackets, we put in the thing that we want to scan. I want to scan the system or the standard input, which is the keyboard. So I want to scan what the user types in. That's what this means. So every time you get input, you have to initialize it like this. And then there's something that you need to clear. That's something that you need to make sure that you solve before, once you're done with your things. You need to always close the scanner. So how do you close it? You use that variable name and you say dot. Remember what a dot means, right? In OOP, right? A dot means that go into that thing and access the thing that's inside of that thing. So for example, if someone sends you to go fetch Coca-Cola, let's say Coke from the fridge, that this would be the same as saying, in other ways I can write it this way. I can say go to the fridge, right? Dot means inside the fridge, grab Coke. So it's pretty much similar to that analogy, right? So I'm saying go within the scanner and then close it, right? That's what it means. So you need to close. This allows us to free memory resources, or else your laptop might actually have issues. You need to make sure you close. It's very dangerous not to close things. So they put the method there for a reason. So close the scanner object after you've used it. And then that's pretty much how we're gonna work. So I forgot to continue making an example here. So when you're printing here, you're gonna pass something as a string, or you can just pass in some variable here. Anything you wanna pass here that you wanna print, right? Don't forget the semicolon, and then pretty much the same thing here. And then for this one, we'll skip for now the printf. We're going to skip printf for now. It's not that important. It's more of like formatted output, like in a complex manner. For example, you're working with like you want to print code names or something like that. You can use printf to print it in such a style, in a beautiful way. You can do that, but that's not what we trying to do. We're trying to make a very basic application. So I want to print the radius, or the area, I mean. So how am I going to do that? I'm going to say system dot out. So remember the dot, it means go within that thing and grab me this thing. And then within the thing that I grabbed, there's also a thing. There's also a thing within it, which is the print line. So dot print line, and then semicolon to terminate that statement or to end the statement. And then here I can pass in the thing that I want to be displayed to the user via the terminal. So I want it to output the area. And then this is a very basic program. So now we can test it out, right? So let's test it out. Our first program. So I'm going to, you don't have to know this, but you need to, okay, you have to know it. What am I saying? You have to know it. You need to go teach yourself command line, commands, right? How to run commands. So I'm going to type dir, which just stands for directory. So it's going to print what's currently in the directory. Folders and all of those things, everything that's currently in the directory is going to print it out. As you can see, it did print them out. And then I want to go to the downloads folder because that's where my main.java is stored. So I'm going to say cd, which means change directory. Remember, directory is an alias for folder. It's another name for folder. So when you say cd, it means change directory or change folder, followed by the name of the folder you want to change to. So I want to move into the folder named downloads. And then enter. When you press enter, you're going to notice something. It changed from this to this. Now downloads there, right? Now you can see that there's downloads here. It means that I've moved into downloads. And I can type dir. Okay, before I do that, let me type clear to clear what's on the screen right now so that you guys can see properly. And then after every command, you need to press enter. So I'm going to press enter, and then you see the terminal is clean, right? And then I'm going to type dir again. And then now I can see everything that's inside of my folder. And you can see I do actually have that main.java, so there it is. So let's compile it, right? Remember, we need to pass the program into a translator to translate from this Java language to the machine's native language. Remember, the computer is very stubborn. It can only speak zeros and ones. It doesn't want to learn any other language. It only speaks its native language, the language that it was born with. So I'm going to say Java C, which stands for Java compiler, followed by the name of the Java file. So main.java, and then I'm going to press enter. If everything goes well, there won't be any errors. If I made a mistake, like I said, you didn't do the right thing, there's going to be an error. I'm going to make an error on purpose after this. And then it's going to create a .class file, right? Which has like, it's called Java byte code, right? By Java bytecode, it means that it's not necessarily the machine's native language yet. We need to pass it into the Java virtual machine, and then the Java virtual machine, it looks at the current operating system that you're using to run the to create the Java programs, and then it translates that Java bytecode to that specific operating system's machine's native language. So I'm going to say Java to run. Remember, you ran Java C first because I wanted to compile it. Okay, before I do that, let me say dir so that you see that we have the main.class file inside here. So main.class, there it is. And then I'm gonna clear because I don't wanna see any. I don't want you guys to be bombarded by information or too much text. So I'm gonna say Java to run followed by the name of the class file. It needs to be a file that ends with .class. So you're gonna say main, and you should remove the .class. Why is that important? Because when you put it by default, Java puts the .class file. So if you run it like this, it means that Java is gonna add another .class, and then now it's gonna be like, I don't know which file is that. So you need to omit the .class. It's gonna edit for itself on its own. It knows, and then you're gonna press enter. Then boom, there's output. So there's our area. But then the area doesn't, we don't actually know what's going on. It's just numbers. In the future, if the user ran this, they won't understand what's going on. So our output needs to be user friendly, right? So the way I'm going to do that is I'm going to have that area there, and then I'm going to output a string, right? And then I'm going to use something called string concatenation. So string concatenation, it just means append this string or this value into the string. So I'm gonna say output the text, the area of a circle is, or I can specify the actual radius, right? So I can say the area of a circle with radius, and then I need to specify the radius, right? I'm gonna put a space there, and then I'm gonna say plus the radius. So radius, and then I'm gonna say plus again, and then I'm gonna say is, and then space, and then I need to put a plus again here. So this is what we call string concatenation. So you take one string and then you add another string to it to form one new string, right? So if you think about it, every word, they also actually use string concatenation. Let me make an example. So if I say let's say Elon, right? The word Elon is basically a concatenation of E plus L plus O plus N, and then you get Elon. It's basically that. So that's what we call string concatenation. So when you combine or you append, imagine you had glue or something to attach these letters next to each other. Or if you remember that name bracelet with those square letters that you usually buy, and then you put it in your on your wrist, and then it forms your name. It's exactly that. That's what we call string concatenation. So you're gonna append all of these strings together to form one big string. And then I'm gonna, so since I need you to pay attention to something, if you don't compile it again, it's going to run the previous version. So if I just say Java main, it only runs the previous version because that's the currently translated version. I need to retranslate so that it puts in the new changes. Before I retranslate, I need to save the changes made in my file. If you see inside Notepad++, there's this orange line, meaning that this is not saved. All of these parts are not saved. So I need to press Control S to save the changes, and then I go back to my terminal. And then I need to recompile. You don't have to retype the commands, you just press the up arrow on your keyboard. So up, that's not what I'm looking for, so I'm going to press up again. That's still not what I'm looking for. I'm going to press up again, up, until I find the command that I'm looking for. So basically, the up arrow, it loads the previous commands that you recently ran. So I'm going to compile, and then it compiled, and then I'm going to press up arrow again, and then this is the one I'm looking for, and then run. And then now the output is a bit friendlier now. It says the area of a circle with radius 25 is this, which is a bit friendlier now, right? I'm sure you can agree to that. It's a bit friendly. So yeah, I hope that makes a bit of sense. So I don't want to go into too much detail because I feel like this tutorial has been quite long. So we're not gonna deal with input just yet. In the next tutorial, we're gonna delve in deep into the input and output part. For now, I just wanted to make a simple program so that you understand how Java works. And if you notice here, if I make it the error, right? Let's say I forgot to check if there's any comments. Okay, there's none. So if you check here, if I remove the semicolon, remember there was a semicolon. If I remove it, my code is an error. Remember what I talked about. The computer is very strict. You need to follow the rules. So if I make that mistake and I save the changes, and then I press the up arrow to run again. By the way, on your first few practicals, you're not going to use an IDE. You're going to do what I'm doing right now. So I suggest you pay attention and you write down and you go practice. This basic what I'm doing right now is basically what you'll be doing. Every time you make a small change, you have to go back and compile and then run, make changes, go back, compile and run using the terminal. So I'm gonna press enter, and then it shows me an error, right? This is what I was talking about. Lucky enough, Java is a bit friendlier than C++. If you're in languages like C and C++, it might not be that user friendly. Unless if you use a different compiler. Compilers are actually very useful. For example, Clang for C and C++, if you use the Clang compiler, which most people use MacBooks use, if you use the Clang compiler, it gives you a sort of like Java way of outputting errors. They're user friendly. You can understand the error. So here it says this is the file. It shows you the name of the file, followed by the line number. It's line number 5, right? So let me try to zoom in a bit. So it shows you the file. It's file main.java, and then it's at line 5, and the error is that there's a semicolon that was expected, and it was expected here. It even shows you the line. It expects it here. I couldn't. This is way too easy to understand compared to other languages. So I need to go back there and put in the semicolon back, and then I need to save my changes. Or if you're using Notepad++, you can go to save all here, or you can just click save. So save all saves all of the files. You might not necessarily want to do that. You might just want to use save, which saves the current open file. So just click save, or just press Control S, and then it's going to save the changes. So I think that's pretty much all I have to talk about, all I have to cover. So let's talk about how to install the IDE and stuff, because I've noticed the version that you guys are supposed to be using is it's not the recent one, and to set it up is actually very complicated if you're a beginner. So let's open Chrome, right? So to install Java, right? To work with Java, I already have it installed. If you look at my taskbar, there's the IDE. It's called Eclipse IDE, right? And I have the correct version, 2023-12. So you're gonna go to your favorite browser, and then you're gonna search download Java JDK, which is the Java development kit or software development kit. And then you're gonna choose the Oracle one from the Oracle company, right? Remember, Oracle is now the company that owns Java, so I would say it's very trustworthy to get the JDK from them than other untrustworthy. Some websites are very dodgy, so don't go there. Just go to Oracle, and then by default, it's gonna show you the latest one. We want the LTS version, which stands for long-term support. We want that one. And as you can see, if, before you scroll down, you can see this bit of information here. They say JDK 23 is the latest release, right? It's the latest, but it's not the stable one. We want the stable one. JDK 23, they might, you see the problem with this latest one, right? Things will crash because it's open to a lot of changes. They can even rechange the whole class that they introduced. So don't choose that one. Choose the LTS version. It's stable. It's more stable. If they make fixes, it's just a small fix. So you don't affect your code base. So the latest LTS is JDK 21. So that means I need to click on JDK 21 here, right? And then I'm going to choose my specific operating system. Since I'm back on Windows for now, I'm going to show you the Windows way, which is good because most of you guys use Windows. But if you're using Linux, if you check the previous tutorial, most people are going to use Debian based distros. If you don't understand what I mean, people who use Linux know what I mean. So if you're using a Debian based distro, you're going to choose this installer. Or if you prefer to download the JDK folder itself and then set things manually, you can do that. I wouldn't advise doing that, but you can do that. You can download here or this one here. But then this one is for ARM processors, right? Don't choose that one. And then this will be the Debian based, right? x64, and then you download. So I'm going to click on Windows because I'm using Windows. For macOS, it should be straightforward. You just download the DMG file. If you're using an ARM processor, right, you choose ARM64. If you're using the Intel chip, you're gonna choose this one, x64 DMG installer. But if you're like those people who like downloading folders or whatever, you can download this folders as they are. That's fine. That's up to you. So Windows, I'm gonna choose Windows for majority of people, and then you can choose the installer. It's either this or this. Any of the two will work. So since I'm using Windows 11, .msi is mainly for Windows 11, but remember, so far, currently, they're about to stop the maintenance of Windows 10. So things are going to shift. It will be a must for you to use Windows 11. But for now, Windows 10 and Windows 11, any files that are downloaded for Windows 11, they can be installed on Windows 10. So that means you can choose any file. You can choose the .msi and then you download, and then this will load, right? And then it's gonna download and install and do all of those things. I already have it installed. And then when this installer is done, you just double click it and then you download, and that's pretty much it. You just click next, keep on pressing next until you reach the install button, and then you click install. I'm gonna show you just now. And then for me it works because once you're done installing, right, you can check if Java is installed by, so let me clear. So you can check if Java is installed by running Java -- version and then press enter. You should show Java 21 LTS, long-term support. This means that Java is indeed installed. In my case, it's already installed, as you can see. In your case, it won't be. So after installing, you should run the command after installing, not before installing. So there's the installer. I know the lecturers, they have their links, whatever. You don't use those. It's very complicated. So you see, it says that this sort of software is already installed. You want to reinstall it? I'm going to say yes, but I'm going to cancel. I'm just saying yes to just show you guys. So it's going to load and do all of those things. So while it's doing that, let's download the IDE, right? So you're going to say Eclipse. download, right? So you're gonna search Eclipse download. So it's gonna ask you for permission, and then you're gonna say yes. Yeah, it needs permission, and then it's gonna load. I don't know why it's taking time. So you see, it's pretty straightforward, to be honest. You're just gonna click next, and then leave the default location. Trust me, default locations are the best thing you can do for yourself. Just leave it as it is, and then next, and then it's gonna install. Oh, there's no install button. Yeah, just keep, like I said, keep pressing next until it installs it. You see, it's going to install the JDK. Now it's installing it. And then it's going to ask you permission again. I already have it installed. I'm going to say no. You should say yes. So after you've said yes, it's going to install and then you're done. Start by installing the JDK. If you do it in another way, vice versa, you're going to have issues. Trust me. So after you're done, you're gonna go to Eclipse or go to your favorite browser and search Eclipse download, and then click the first link. It's usually the first link, or you can see the link here. It's eclipse.org/downloads/, and then it's gonna land you to the downloads page to download Eclipse. So there's Eclipse. You guys are not. I'm gonna repeat this again. Do not download the latest version for UJ students. Do not download the latest version. Your practicals are not going to compile at all. You're going to get 0, like a big fat 0. Do not do that to yourself. You're going to click download here, right? You don't want to download this one. Why do you want to download this one? Because that's the latest. How can you find out that that's the latest? You see the version at the top. You see a version here. It's 2024-09. We do not want that. If you check the version on eve.uj.ac/resources/CSC, CSC stands for Comp Sci. So if you check Computer Science 2, right, second year Computer Science, you need to download this JDK, Java FX, the Eclipse. You see the Eclipse, you see the version that they told you to install. It's 2023-12. That version, you need to go back to that same link, right? Type that version. Come here and say 2023-12, like that. And then you're going to press enter. And then it's going to reload. You might not see the difference, but it did actually change. You see now it shows 2023-12. That's the version you are looking for. And then you click on this installer and then you just download, or this download button. It's literally there. It's up to you. This is using the SHA-512. You don't have to worry about that. So you can either download this way or this way. So let me just click download here. And then the download is going to start. And then there it is. And then it downloads. And then I'm going to open it. At least lucky enough the Wi-Fi is a bit faster today. So I'm going to show you how to install it. It's very basic. It's easy to install. Remember, we have our Java set up. So if I run Java version, okay, my bad, it did remove it, so now I need to redo this thing again. I was not supposed to do that, so it removed the Java. So let me install it again. So let's wait for the permission. It's gonna ask me for the permission. Remember, you install the JDK first before you install the IDE. If you do it in your own way, things are not gonna work. And then close. I have Java installed, and then let me run the command now. Yeah, now it's fine. Java is indeed installed. So after installing, you see that Java will be picked up. Java C. You can also check the version of your compiler. Java C version, and then there it is. And then you know you're good to go. And then you can open the Eclipse installer now. So I know it's a bit hard to download, but yeah, you know these things, they're not easy to set up. This is a bit better compared to, especially if you guys like play around and you go into game development. It might take you the whole week just trying to set up the IDE. So this is nothing compared to game dev. So you see that there's many IDEs here. You scroll down, you see there's many. For Eclipse committers, PHP developers, C or C++ developers, we don't want any of those. And we also do not want enterprise. We are not a company. We are not working for a company. We're just students, right? You guys are just students. So we want this one, the Eclipse IDE for Java developers. And then you're going to click that. By default, it should pick up your JDK. That's why I said install it first. You see, there's the JDK. You could, technically speaking, you don't necessarily have to install it first. You could just select it from this list of options here. You see that C drive program files, that's the one local, that's the one on my computer. Or I can just press the down arrow to choose a different JDK, but it's gonna download it from the from the internet or from the cloud. We do not want that, because remember, in your first few practicals, you guys are not going to be using an IDE. I think the first two practicals, no IDE. You're going to use the terminal and a text editor of your choice, whether it's VS Code or Notepad++ or Atom or Sublime Text, whatever your favorite text editor is. And then you can you can allow it to create a desktop shortcut. I don't like it. I would just deselect that or unselect it, and then make sure that the create start menu entry is checked. Because if you don't check it, when you press the Windows icon on your keyboard and then you search for Eclipse, it won't show. If you unselect start menu, it won't show when you search it. You'd have to look for the folder and then look for the executable and then run it there, which is a lot of work. So allow it to create the start menu and then you click install and then done. That's pretty much all you have to do to install the IDE. To set up Java is now global. You can run it from the terminal or from your IDE. Then you're good to go. You'll be all set up. So I think that's all you guys need now. That's all you guys need to know. And if you need any info, if you need any more, if you have any questions, just let me know. Just type them down in the comment section. Just let me know if you have any questions. And that's up. I guess that's it for today. Please don't forget to like, comment, and subscribe. Thank you for watching.